Dear students, welcome to my third class on Module 2 Fourier series. In this lecture video, we're going to discuss about periodic functions of period 0, 2 pi. So Fourier series expansion over the interval 0, 2 pi, the formula is f of x is equal to a0 by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity bn sin nx. So where this a0 is given by 1 by pi integral 0 to 2 pi f of x into dx, an is given by 1 by pi integral 0 to 2 pi f of x cos nx dx for n is equal to 1 to 3, and bn will be equal to 1 by pi integral 0 to 2 pi f of x sin nx dx for n is equal to 1, 2, 3. So the problems on the interval 0, 2 pi. Obtain the Fourier series of f of x is equal to pi minus x by 2 in 0 less than x less than 2 pi, and also deduce that 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on will be equal to pi divided by 4. So the first thing is always take the main formula of f of x. So here f of x is equal to, we have a0 by 2 plus summation n from 1 to infinity an cos nx plus summation n from 1 to infinity bn sin nx, and call it as equation number 1. So now I'll be finding the values of a0, an as well as bn. So they have given that the function f of x is equal to pi minus x by 2 in the interval 0, 2 pi. So now I'll be finding the value of a0. So a0 is equal to, we have the formula like 1 by pi integral 0 to 2 pi f of x dx. In the place of f of x, I am going to replace the function f of x is equal to pi minus x by 2. So I got 1 by pi integral 0 to 2 pi minus x by 2 into dx. Now the constant 1 by 2 will shift outside. So I'll be getting 1 by 2 pi, the integral 0 to 2 pi minus x dx. So after integration, we got 1 by 2 pi into pi x minus x square by 2 with the limit 0 to 2 pi. So applying upper limit, replacing all x terms by 2 pi, minus applying lower limit, replacing all x terms by 0. So we got 1 by 2 pi into 2 pi square minus 4 pi square by 2, and lower limit will be 0. So after simplifying this, we'll be getting 1 by 2 pi into 2 pi square minus 2 pi square. The value will be equal to 0. So now I'll be finding an. So to find an, the formula is 1 by pi integral 0 to 2 pi f of x cos nx dx. So in the place of f of x, replace pi minus x by 2. So we got 1 by pi integral 0 to 2 pi minus x by 2 into cos nx. The constant 1 by 2 I'll shift outside. So we got 1 by 2 pi into pi minus x into sin nx by n minus 0 minus 1 into minus cos nx by n square with the limit 0 to 2 pi after the integration by applying Bernoulli's condition. So now we'll be applying the limit, applying upper limit, replacing all x terms by 2 pi, and lower limit, replacing all x terms by 0. So upper limit, so 1 by 2 pi into pi minus 2 pi sin 2n pi divided by n minus cos 2n pi by n square, minus lower limit, replacing x is equal to 0, we'll be getting pi minus 0 into sin 0 by n minus cos 0 by n square. So as we know that sin 2n pi will become 0, sin 0 also 0, so cos 2n pi is 1, cos 0 is also 1. So we got 1 by 2 pi into 0 minus 1 by n square minus plus 1 by n square. So the value of an will be 0 after cancelling 1 by n square equation. So we got both a0 as well as an is 0. Now I'll be finding bn. So bn is equal to, we have the formula 1 by pi integral 0 to 2 pi f of x sin nx dx. So replacing f of x as pi minus x by 2. So now we got the equation like 1 by pi integral 0 to 2 pi minus x by 2 sin nx dx. The constant 1 by 2 will shift outside. So we got 1 by 2 pi into pi minus x into minus of cos nx by n minus 0 minus 1 into minus sin nx by n square with the limit 0 to 2 pi after applying the integration. So now applying upper limit, replacing x is equal to 2 pi and lower limit x is equal to 0. So we got 1 by 2 pi into pi minus 2 pi minus of cos 2n pi by n minus sin 2n pi by n square minus pi minus 0 into minus of cos 0 by n minus sin 0 by n square. As we know that sin 2n pi is 0, sin 0 also 0, cos 2n pi is 1, cos 0 is 1. So we got the value like 1 by 2 pi into minus pi by n plus 2 pi by n plus pi by n after simplification. So we got the equation like bn is equal to 1 by 2 pi into 2 pi by n. So the value of Bn will be equal to 1 divided by n. So now I'll be replacing all these a naught, a n, b n in the equation number 1. So we got f of x is equal to 0 plus 0 plus summation n from 1 to infinity 1 by n sin nx. So we got pi minus x by 2 is equal to summation n from 1 to infinity sin nx by n. So now we have to find the next part. To find this next part, I'll be replacing x is equal to pi by 2. So I'll be putting x equal to pi by 2 in the equation number 2. So we got pi minus pi by 2 is equal to summation n from 1 to infinity sin n pi by 2 by n. So expanding summation, we got pi by 4 is equal to sin pi by 2 plus 1 by 2 into sin 2 pi by 2 plus 1 by 3 into sin 3 pi by 2 plus 1 by 4 into sin 4 pi by 2 and so on. So after simplifying this, we got 1 plus 1 by 2 into 0 because sin pi is 0, sin 2 pi also 0. So we got 1 by 3 into minus 1 because sin 3 pi by 2 is minus 1 and so on. So after simplifying this, we got pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on is the required solution. Example number 2, express f of x is equal to pi minus x whole square as a Fourier series of period 2 pi in the interval 0 less than x less than 2 pi. Also deduce 1 plus 1 by 2 square plus 1 by 3 square and so on is equal to question mark. So same like a previous problem. So first take the function f of x, the formula that is a naught by 2 plus summation n from 1 to infinity a n cos nx plus summation n from 1 to infinity b n sin x. Call this one as equation number 1. So now they have given that f of x is equal to pi minus x square, x whole square. So now we'll be finding a naught, a n as well as b n. So to find a naught, the formula is 1 by pi integral 0 to 2 pi f of x dx. The place of f of x, replace pi minus x whole square. So we got 1 by pi into integral 0 to 2 pi pi minus x whole square into dx. So keeping 1 by pi as it is, after integration of pi minus x whole square, we'll be getting pi square plus x square minus 2 pi x by expanding by using a minus b whole square formula. So now I'm going to integrate this equation. So we got the equation like 1 by pi into pi square x plus x cube by 3 minus 2 pi x square by 2 with the limit 0 to 2 pi after integration. Okay, now I'm going to apply the upper limit replacing all x terms by 2 pi and lower limit applying all x terms by 0. So for upper limit, I got the equation like 1 by pi into 2 pi cube plus 8 pi cube by 3 minus 4 pi cube and lower limit will become 0. After simplifying this, we got a naught is equal to 1 by pi into 2 pi cube by 3. Therefore, the value of a naught will be equal to 2 by 3 pi square. So now I'll be finding a n. The formula for a n is 1 by pi integral 0 to 2 pi f of x cos nx dx. So in the place of f of x, replace pi minus x whole square. So we got a n is equal to 1 by pi minus x whole square into cos nx dx. So now I'll be treating this as u, this one as v, applying the Bernoulli's condition. So the first term, constant 1 by pi, I'll keep as it is. So first keeping u term as it is, integrating cos nx, we got sin nx by n minus. So now solving pi minus x whole square with respect to x. So we got 2 into pi minus x and solving minus x, it is minus 1. And solving sin again, we'll be getting minus cos nx by n square plus minus 2 into minus 1 into minus sin nx by n cube with the limit 0 to 2 pi. So applying the upper limit, as you know that, so sin 2n pi will become 0. For lower limit also sin 0 and sin 0 will become 0. So we got the equation like 1 by pi minus 2 pi whole square into sin 2n pi by n minus 2 into pi minus 2 pi into cos 2n pi by n square minus 2 into sin 2n pi by n cube. And lower limit is pi minus 0 whole square sin 0 by n minus 2 into pi minus 0 into cos 0 by n square minus 2 into sin 0 by n cube. So sin 2n pi is 0, sin 0 also 0, cos 2n pi is 1 and cos 0 also 1. So after simplifying this, we got the equation like 1 by pi 0 plus 2 pi into 1 by n square plus 2 pi plus 1 by n square. So it will become n is equal to 1 by pi 4 pi by n square, or the value of n is 4 by n square. So now the last coefficient is bn. So bn is given by 1 by pi integral 0 to 2 pi minus x whole square into sin nx dx. So applying the Bernoulli's condition here also, taking u as pi minus x whole square and v as sin nx, applying the Bernoulli's condition. So after integration, we got the equation like 1 by pi minus x whole square into minus cos nx by n minus 2 into pi minus x into minus 1 minus sin nx by n square plus minus 2 into minus 1 into cos nx by n cube with the limit 0 to 2 pi. So applying the limit, so applying upper limit, replacing all x terms by 2 pi So we got 1 by pi into pi minus 2 pi whole square into minus cos 2n pi by n minus 2 into pi minus 2 pi sin 2n pi by n square plus 2 into cos 2n pi by n cube. So next is lower limit, applying all x is equal to 0. So we got pi minus 0 whole square into minus cos 0 by n minus 2 into pi minus 0 into sin 0 by n square plus 2 into cos 0 by n cube. So after applying that, sin 2n pi is 0, sin 0 is 0, cos 0 is 1, cos 2n pi is 1. So we got bn is equal to 1 by pi. So we got this equation. So after simplifying this equation, we got the value of bn will be equal to 0. So now we'll be replacing all these coefficients a0, an, bn in the equation number 1. So we got f of x is equal to 1 by 2, 2 by 3 pi square plus summation n from 1 to infinity 4 by n square into cos nx plus 0. So after simplifying this, we got pi minus x whole square is equal to pi square by 3 plus 4 into summation n from 1 to infinity cos nx by n square is the required Fourier series. So now to find the next part, I am going to replace x is equal to 0 in the previous equation. So we got pi minus 0 whole square is equal to pi square by 3 plus 4 summation n from 1 to infinity cos 0 by n square. So expanding the summation, we got pi square minus pi square by 3 is equal to 4 into 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on. Our 2 pi square by 3 will be equal to 4 into 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus so on. Taking 4 to LHS, we got pi square by 6 is equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square and so on is the required solution for the given equation. Thank you.